All right, boys and girls, welcome back to the drive-thru. As always, the drive-thru is sponsored by the deli. Today, the deli would like to recognize Thanksgiving. Thanksgiving is possibly the greatest holiday because it truly involves all people. It doesn't matter what religion you are. It doesn't really matter if you love America or don't love America, you know, like the 4th of July. You don't have the pressure of giving gifts. You just are simply supposed to take time to reflect and be thankful for things. And in today's negative world, it may not have ever been so important to take a little bit of time to be thankful and appreciative of how actually wonderful the world is. So, all right, this is a tough case of the missing diagram. And so when you draw planes, my best advice to you is draw them like really flat parallelograms, okay? So from any point on a line perpendicular to a plane, okay, two lines are drawn oblique from the plane. So here is the foot of our perpendicular blue line. I'll draw two oblique lines, a pink one and a green one. If the foot of the perpendicular is equidistant from the foot of the oblique line, so these black dots represent the feet of the oblique lines, and the green dot represents the foot of the perpendicular line. So if these two black lines are congruent, segments are congruent, prove that the pink line is congruent to the green line. Okay. So if I walk through my plan, I know that this blue line has to be perpendicular to both of the black lines. Do you see that? I also know that these black lines are congruent because that's given. And do you see the one other key piece of information that we can take out of there? Yes, this blue line is congruent to itself. So while I thought this was going to be HL, it's not. It's actually going to be side angle side. Okay, so I think I've got it done. I just have to now do the proof right. So let's see, what am I given? Well, I'm going to have some letters. A, B, E, S. Abes. Go Abes. Okay. So, I'm given that AE, let's call this M. AE is perpendicular to plane M. I know that SE, or E, is equidistant from S and B. I think that's all I know, right? Okay, so the first thing I'll say is that AE is perpendicular to SE and BE. And here's the theorem that everybody loves to hate. If a line is perpendicular to a plane, then it is perpendicular to all lines that travel through the foot okay. I know that SE is congruent to BE, and that's definition of equidistant. I know that angle AES and AEB are right angles. I'll just write if perpendicular, then right. Or definition of perpendicular would be fine for that. I know that AES is congruent to angle AEB. And that would be all right angles congruent. I know that AE is congruent to AE. And that's reflexive. Okay. So now I think I'm going to be able to say that triangle AES is congruent to triangle AEB. By SAS. And then I know AS is congruent to AB by CPCTC. Let's hear it for Thanksgiving. Can I get a boom?